This example was sent in from a student, and I'm so thankful to have received it. This is an excellent example of some of the simplifying that we can do with radical expressions. Specifically, this example is asking us to rationalize the denominator. The first step is to understand what that means. What does it mean to rationalize a denominator? I'm going to rewrite this radical as the fourth root of 16 over 9x to the 6th. It's the same thing as the fourth root of 16 over the fourth root of 9x to the 6th. So that's the first step. Now, when we go to rationalize the denominator, there are a couple different approaches. The first approach is to simply memorize a list of steps. Do this, this, etc. But a better approach is to understand the process, and then those steps will just fall into place naturally. That's really the goal, is that you would get to that point where you really understand these steps, and then it just happens naturally. And I'm going to work through this problem in such a way that I'm going to attempt to explain the steps in the hopes that maybe you'd get to where you don't really have to rely on a list of steps. The first step, however, if you're thinking, oh, what's the list of steps, is to understand what we would need to multiply this 9x to the 6th times to be able to get rid of this radical. So the goal of rationalizing the denominator is to have an expression where it could be rational, or in other words, written as a fraction. That's okay. We can have a denominator, but what we want is to not have a radical in the denominator. So what we need to do is look at this 9x to the 6th fourth rooted and think, what could I multiply that times so that I have 4 of each factor, and therefore it would be removed from that radical. To do that, I need to think of what the basic pieces are of each of these factors. So for the 16, I could see it as a 2 times 2 is 4, times 2 is 8, times 2 is 16. I can see that as the fourth root of 2 times 2 times 2 times 2. For the 9, if I got the prime factors, a 9 is a 3 times 3. And then, you know what I'm going to do? I'm going to write this x to the 6th as a group of 4, and then we see that we have 2 left over, right? So I've not really changed the value. I've not really done anything to the problem. I've just rewritten it, expanded it as a product of prime factors. And when I see this numerator, by the way, I'd recognize, oh, I've got 4 of a kind. Why was I looking for 4 of a kind? If this index is 4, then as soon as I have 1, 2, 3, 4 of something, then I can remove it from the radical. So in other words, the fourth root of 2 to the 4th power is 2, because this 4th power and this 4th root cancel each other out. So I'm left with a 2. So in the numerator, in the top, we've got a 2. In the denominator, you see that we've got this x to the 4th. The 4th root of x to the 4th cancels each other out. So this x, the x to the 4th, comes out of the radical as just an x. So you see what we have left is 2 3s and 2 x's in there. Let me write that down below here. So I'm looking at this thinking, well, what would I need to insert in or multiply by so that I have 4 of a kind? Well, I have 2 3s, so you could see that if I had 2 more 3s, I'd have 4 3s. I can't just put those two 3's in. And remember that they were in the fourth root. In order to insert a 3 times 3 so that I could get 4 of a kind, I could write that in the numerator also. So what I've done is I've multiplied the top and the bottom by the fourth root of 9. I wrote that in the form 3 times 3, but it's 9. And then for the x's, do you see that what we would need is 2 more x's? So I'm going to do that to the numerator also. And now, what do we have? We've got 4 x's, so that can come out as an x. Now, be careful, because the fourth root of 4 x's is just one of the x's, right? The fourth root of x to the fourth and the fourth root cancel each other out. They undo each other, and we're left just with this x. So be careful that you're not carrying it out and calling it an x to the fourth, right? And then for the 4 3's, same thing. I've got 4 3's. It comes out as 1 3. All together, what do we have left? It looks like we've got in the numerator 2 times the fourth root. Don't forget that index 4 when we write the radical. 3 times 3 is 9. X times x is x squared all over 3 times, oh, what is that? Yeah, 3 times x squared. 3 times x squared. Well, I hope that this example has helped. If you need a further explanation or need more guidance with this, please don't hesitate to contact me.